Hello and welcome back. In this video we'll be looking at section 3.4 on how to find zeros of polynomial equations. And essentially when we're given a function that's a polynomial, being able to factor it is the easiest way of finding all of the zeros. So if I want to find all the zeros of this function, essentially what I want to do is I want to solve when this is going to be equal to 0. And if I've factored my polynomial and it looks something like this, I know exactly what all the zeros are going to be. If I have a bunch of things that are being multiplied, the only way that I can multiply numbers to get 0 is if one of those numbers happen to be 0 to begin with. So if I want to solve when this is equal to 0, I need to say x plus 2 is equal to 0, or I can say x minus 7/3 is equal to 0, or x minus square root of 2 is equal to 0, or x plus 4 minus I is equal to 0, or x plus 4 plus I is equal to 0. And each one of these I can just move the number to the other side and see that, so x would be negative 2 here, or x would be equal to positive 7/3 here, and so on and so forth. Now, sometimes the roots, the zeros of a polynomial are going to be integers. So here we have negative 2, this is an integer. We could have it be not an integer, but still rational, as in an integer divided by an integer. These are still nice. Or, for instance, here this would be x is going to be equal to the square root of 2. The square root of 2 is not rational. It can't be expressed as an integer divided by an integer. So these are maybe not quite as nice to work with. They do exist, they can happen. And then in these last ones, so for instance this one here, x would be negative 4 minus I. And this can also happen. You can also have zeros that are imaginary or have an imaginary component, so they're complex numbers. So what I want to do is I want to focus on rational zeros for the moment, because these are, in a sense, the nicest ones. They're the easiest ones to understand. And it turns out we know exactly what the rational roots of a polynomial can be. So if you have some polynomial, and it's something times x to the n plus something else times x to the n minus 1 plus down all the way down to something times x squared plus something times x plus the constant term, so as long as each one of these is an integer, so as long as each one of the numbers that we're multiplying our x's by, as long as all of these are integers, then we know exactly what the rational zeros are going to be. We can't say anything about the irrational zeros or the complex zeros, but the rational ones have to be p divided by q, where p divides the constant term and q divides the first term. And I think the easiest way to see this is through an example. So what we're going to do is I'm going to write up a polynomial, and we're going to look at all of the things that divide the constant term and all the things that divide the leading term, and we'll get some rational numbers from that. So let's find all the possible rational, I want zeros here, all rational zeros of x cubed plus 2x squared minus 5x minus 6. So what we need to do is look at all of the factors of the last term and all the factors of the first term and write them down. So all of the factors of negative 6, looking at all the whole numbers, all of the integers that divide negative 6. Well, 1 divides negative 6, and to be a little bit more succinct, not only does 1 divide negative 6, but negative 1 also divides negative 6. So plus 1 and negative 1. 2 also divides 6, so plus 2 divides it, but so does negative 2. 3 divides 6, and so does negative 3. And 6 divides 6. but also we can have 6 divides 6 and negative 6 divides 6. So we have 8 factors of negative 6, plus 1, minus 1, plus 2, minus 2, plus 3, minus 3, plus 6, and minus 6. So we have all those. And now let's look at all the factors of 1, because 1 is the coefficient of the leading term here. Well, the only number that divides 1 is 1, but we could also say negative 1 divides 1. So considering positive and negative numbers, these are all the numbers that divide 6, and these are all the integers that divide 6, and these are all the integers that divide 1. So the possible rational factors are, we're going to take all of the factors that divide the 6, and we're going to divide them by all the factors that divide 1. So I could take 1 divided by 1, I could take 2 divided by 1, I could take 3 divided by 1, and I could also take 6 divided by 1. And if we think about positive and negative numbers, well, either one of these could be positive or negative, so I could get a positive 1 divided by 1, a negative 1 divided by 1, 1 divided by negative 1, or 1 divided by positive 1. We can just consider all of the combinations of positive and negatives here. So if I simplify these, the factors are going to be plus or minus, sorry, the rational zeros are either going to be plus or minus 1, plus or minus 2, plus or minus 3, or plus or minus 6. Now, these are all of the possible factors. I keep calling them factors. These are all the possible zeros, but it doesn't mean that they all are. These are the only ones that we would have to check. Okay. Let's look at another example really quick. So let's look at all the possible rational zeros of this guy here. So we first look at the constant term. The constant term is way back here without an x. And what divides 3, or I should say negative 3? Well, we could have plus or minus 1, and we could have plus or minus 3. No other number divides 3. And then let's look at the factors of 4. Well, plus or minus 1. 2 divides 4, so plus or minus 2. And 4 divides 4, so plus or minus 4. So if we look at all of the possible rational zeros, we want to take the factors of the constant term and divide it by the factors of the first term. So we could have plus or minus 1 over 1, plus or minus 1 over 2, plus or minus 1 over 4, or we can have plus or minus 3 over 1, plus or minus 3 over 2, or plus or minus 3 over 4. So these are all of the possible rational zeros. If I simplify each one, this would be plus or minus 1. This is plus or minus 1/2, plus or minus 1/4. This is plus or minus 3, plus or minus 3/2, or plus or minus 3/4. So all of these are going to be the possible rational zeros, but we have to go through and check each one to see which ones are actually zeros of the function or not. So let's actually do that. Let's go through an example where we list all of the possible rational zeros, figure out which ones are. So when we look at this, we want to find all the factors of negative 20, the constant term out back. So we can have plus or minus 1, plus or minus 2, 2 divides 20, 4 divides 20, so plus or minus 4, 5 divides 20, 10 divides 20, 20 divides 20. So that's a lot of factors there. But then luckily our first term, we only have a 1 as the coefficient. So the only factors of 1 are plus or minus 1. So the possible rational zeros are, well, we can have plus or minus 1 divided by 1, plus or minus 2 divided by 1, plus or minus 4 divided by 1, plus or minus 5 divided by 1, plus or minus 10 divided by 1, plus or minus 20 divided by 1. So these are all the possible rational zeros, but we don't know which ones are actually zeros and which ones aren't. So let's go through and check. And to do this, I'm going to start with the easiest one, which is just going to be plus 1. It's generally easier to choose some of the smaller ones, the ones that are closest to 1 or negative 1, in fact. So let's plug 1 into here and see what we get. We get 1 cubed plus 8 times 1 squared plus 11 times 1 minus 20. Simplifying, 1 cubed is 1. 1 squared is 1 times 8 is 8. Plus 11 times 1 minus 20. And oh, hey, look, that equals 0. So we got lucky. On our first try, our possible rational zero worked. So what does this mean? It means that 1 is a 0. But there will be more. So we'll need to go through and check. But we can use something that we learned in the last chapter. If we know that a number is a 0 of a polynomial, this means that I can factor the polynomial very easily. So this means that x minus 1, so x minus a 0, is a factor of f. So once I know one factor of f, I can figure out the other ones. So if I write f down, so this is plus 8x squared plus 11x minus 20, I know one factor. So how do I find the other? How do I find the other one? I divide by that factor. Again, if I divide by that factor, what I get times the first one should be this whole thing. So again, I'm just going to divide and everything should work out. So here, if I divide x cubed plus 8x squared by x minus 1, I'll get x squared. So if I take x squared times x, I get x cubed. X squared times negative 1 will be negative x squared. I subtract, so those will cancel. 8x squared minus negative x squared. If I subtract a negative, it's the same thing as adding. I bring the term down. X minus 1 divides 9x squared plus 11x. This will go 9x times. If we take 9x times x, I get 9x squared. 9x times negative 1 is going to be negative 9x. Again, I subtract. 9x squared minus 9x squared is 0. Perfect. 11x minus negative 9x. So again, I'm subtracting a negative, so it's the same thing as adding. So I will get 20x. Pull that down. X goes into 20x 20 times. 20 times x is 20x. 20 times negative 1 is negative 20. And this confirms what we already knew. These cancel and these cancel. So I have a remainder of 0, which means that x minus 1 divides my polynomial evenly, which I knew it should because it is a factor of the polynomial. So let's write this down. Our polynomial, what we originally had, is now going to be x minus 1 times the quotient, x squared plus 9x plus 20. And the nice thing here is that this polynomial factors pretty easily. If we look at this, this will be x plus 4 and x plus 5. Why? 4 times 5 is 20, but 4 plus 5 is the 9. So my function, I had to find the first factor. The first factor was hard. The rest of it was easy. So when I factor this, this means x is equal to 1, x is equal to negative 4, or x is equal to negative 5.